Do you have any question? Do you have any question? Okay, for those who want to redo the quizzes and the exam, the deadline is midnight today. So I will not accept anything from midnight. Okay? So if you want to redo your test or your quiz, the deadline will be midnight. Else, if you've not done the quiz or the test, then you've not repeated it, then you will still get your same marks. If you've not done the quiz, then you will get a 0. All right? Okay. So if you have any genuine reason, I can still give you some time. So if you talk to me, you write a mail, then I can still give you some time to do it. All right? Okay, so today we are looking at section 8.3. Is Laura here? Laura. So let's look at section 8.3. And this one is simplify rational exponents. Simplify rational exponents. Simplify rational exponents. Okay, so if the nth root of A is a real number, if the nth root of A is a real number, and n is greater or equals to 2, and n is greater or equals to 2, then the nth root of A is similar to A raised to 1 over n. So the nth root of A is equals to A that raised to 1 over n. So this is a radical. And this one is the one? Rational expression. Rational. So because there is an equal sign here, so this is rational. So this is a radical, and this one is a rational expression. Now, if we still remember I think we did the properties of exponents. Do you still remember the properties of exponents? We have the product property, the power, the quotient. I think we did that like at the beginning of the semester, right? So, like, if you remember the properties, like, let's say the product property, where we said A M, maybe A M same as A N is similar to what? A M plus what? Plus N, right? Then, if you still remember the quotient property, let's say M all over A N is similar to what? A M minus what? Minus N. So those are the properties that we did. So we are going to apply these properties now in the radical or rational expressions. So again, if we are given A raised to M all over N, A raised to M all over M, A raised to M all over N, then this is equals to A raised to 1 over N raised to what? Raised to M, right? This is also similar to A raised to M and then raised to what? 1 over N. So if you use the power property, which we did, this is the power property, right? So where we are multiplying the powers, so the power property. So like we can factor out the M there, we can factor out the 1 over M. That is similar to that. Also, this is similar to what? The nth root of what? Of A, then raised to M. Okay? And also, this is also similar to the nth root of A raised to what? A raised to M. A raised to M. So all those are the same. They are all the same. Again, we had the zero property where we said if we raise anything by 0, we still get what? 1. Still get 1. Again, if we have A raised to minus, let's say minus N, A raised to minus N is the same as what? 1 over what? A raised to N. So similar to that. Also, if we have A raised to minus 1 over N, it is still similar to 1 all over A raised to 1 over N, which is still similar to 1 over the nth root of what? Of A. Okay, now let's come to the examples. How can we use these concepts to solve some of the expressions? So example number 1. Example number 1, we have in our notes. So the first one is simplify y raised to 1 over 2 times y raised to 3 1 over 4. Y raised to 1 over 2 and y raised to 3 all over 4. So which kind of approach can we use this? So the bases are what? The bases are the same, right? So what do you do to the power if there is a product here? So this is a product. So if we have a raised to m, like what we did that, raised to n is the same as what? A raised to m plus what? Plus n. So here is still the same thing. So this is the same as a raised to 1 over 2 plus 3 over 1. 4. A raised to 1 over 2 plus 3 over 4, which is equals to y raised to what? 1 over 2 plus 3 over 4. What is this? Is it 5 over 4? So y raised to 5 over 4, which we can still write as, so we can still write this one as y raised to what? 5. So we can still write that like that. Because this is like y raised to 5 over 4 is similar to y raised to 1 over 4 raised to what? 5, which is equals to the fourth root of what? Of y raised to what? Raised to 5. Which is also similar to y raised to 5 raised to 1 over 4. And this one is equals to what? Y raised to what? Y raised to 5. Y raised to 5. Any question? Okay, let's come to example number 2. Example number 2. Nine x raised to 2 over 5, and then y raised to 3 over 5, and then all this raised to 5 all over 2. Simplify y, and 9x raised to 2 over 5 times 3 over 5, and then raised to 5 over 2. So what do we use? We use the power property. Okay? So we use the power property. So before we use the power property, we can still get the what? The factors of 9 here. So which is similar to 3 raised to 2, x raised to 2 over 5, and then y raised to 3 over 5. All these raised to what? 5 all over 2. Now, using the power property, then this is also equals to 3 raised to 2. You multiply each power by what? 5 over 2 times 5 all over 2 times x, 2 over 5 times 5 all over 2 times y, 3 over 5 times 5 all over 2. So now we cancel the ones which we can cancel. So by 2 and 2 will go. This 5 and this 5 will go. This 2 and this one. Then this 5 and that 5 will cancel. So what do we remain with? 3 raised to what? 5. X raised to what? This is 1, right? And then y raised to 3 over y raised to 3 all over 2. Y raised to 3 all over 2. So either way, we can leave it like this, or what is 3 raised to 5? What is 3 raised to 5? 201. So this is equal to 243 x y raised to 3 all over 2. Y raised to 3 all over 2. Okay, so let's come to example number 2, example number 3. So example number 3 is, so as said, this is in terms of, so this raised to n, this is the radical expression. So you can be told to write this one in rational exponent form. So in rational exponent form. So how will you write that? So in terms of rational exponent form, then this is the same as 1 over what? A raised to 1 all over. So this is in radical form, then this is in rational exponent form. So rational exponent. Now, we can be given a question like the one which we have in our example. 8 and then the 5th root of 4x. Then the question can be, write this one with rational exponent. So with rational exponent. So how should we write this one in rational exponent form? So how should we write this in rational exponent form? So 8 will still remain the way it is. So 8. And then this will be what? 4x. And then raised to what? 1 all over 5. So this is in rational exponent form. Another example, write 6 and then the 5th root of 8x in or with rational exponent. With rational exponent. So how should we write that? So this is equals to what? 6 and then 8x. All is raised to what? 1 all over 5. So there are examples there which are similar on how to do this, as long as you know how to write in this form. So if you're given like a raised to m here and then n here in rational exponent form, this is similar to am all over what? All over am all over n. So like, for example, the cube root of w raised to 5, the cube root of w raised to 5 is equals to 1 over 3, okay? And this is equals to what? This is equals to that. So using the power property, use the power property. So now, how should we convert the rational to power, and now to radical? So now converting the rational to radical. So if our rational is a raised to m all over n, so this is rational, huh? So converting back to radical is the same as a raised to m and then raised to 1 over n, which is equals to the nth root of a raised to m. So this is now the radical. The radical. So this is the radical. Now, for example, y raised to 3 over 2. Write this one in as a radical expression. Write as radical expression. So y 3 over 2 is similar to y cubed. All this raised to 1 over 2. So in radical expression, then this is equals to the square root of y raised to 3. The square root of y raised to 3. You have any question? Another example. Simplify. Simplify negative 16 raised to 3 all over 2. Simplify negative 16 raised to 3 all over 2. So how should we simplify this? How should we simplify this? Okay, looking at this negative here, I don't think it affects the what? The power there. So this is equals to negative 16 raised to what? 3 over 2. This equals to negative 16 raised to 3 over 2. So we can look for the factors of what? Of 16. Okay, again, we can still write this as what? Negative 16 cube. All this raised to what? 1 over 2. Or to make it simpler, because it might be hard to find the cube first than the root. So what you do, you start by solving the what? The root. So it will be, so you start by solving like this, 16 raised to 1 over 2 cube. 16 raised to 1 over 2 cube. So you start from the roots. So the root is 1 over 2 there. So equals to negative 16 is 4 by what? 4, which is the same as 4 squared. Okay? And this 4 squared, using the power property, raised to what? 1 over 2. All these raised to cube. All that raised to cube. Finally, what do you get? That will cancel. Then we get minus 4 and then raised to 3. So minus 4 raised to 3 is equals to what? Minus what? Minus what? What do you get? 64. Get minus 64. Is that clear? So you can start from the root and then you cube. Another example. Simplify 32 raised to negative 2 all over 5. 32 raised to negative 2 all of 5. So simplify. Simplify this. So how should we simplify that? So we can write this as 1 all over what? 32 raised to what? 2 over 5. 1 all over 32 raised to 2 all over 5. then we can get so again, this is equals to, so I said you can start by getting the root. So 1 all over 32 raised to 1 over 2, all this raised to what? Raised to 5. So what are the factors of 32? Oh, what am I doing? So this should be what? 5, and this one should be what? 2. So it should be equals to 1 all over 32 raised to 1 over 5, and then the square. So what are the factors of 32? So we have 2 raised to 5 equals to what? Is it 32? So 2 times 2 times 2 times 2 times 2. So this is 4, this is 4, this one is 2. So this is 16 times 2. So this is 32. So 2 raised to 5. So equals to 1 all over 2 raised to 5, and then this raised to 1 over 5. All these raised to what? Square. All that raised to square. Now using the power property, then this will cancel with that. So finally what we get is 1 all over 2 raised to 2. This is equals to 1 all over 4. 1 all over 4. The second last example. Simplify r raised to 5 all over 2 multiplied by r raised to minus 1 all over 2 divided by r raised to minus 3 all over 2. So I think I gave almost similar question like this in the first question in your exam, but the other one was not a rational. Huh? So here we use how many properties here? So we have the product, we have the quotient there. So the bases are all the same here. So this base, this one are the same. So for the top one, we add the powers, right? And then we bring this one up here. So when we bring this one up here, it will be what? Positive, right? So this is equals to what? So you can start from the top one. So again, when you're doing your exams, yeah. So if you write the steps, it will be so simple for me to follow, right? The way you've seen me doing here, I wish you could be following the same thing when you're writing your exam. It would be so simple. And even it will be so simple for you to identify where you're making a mistake. But if you scribble, you move from this point, I don't know how you're writing, then you will make some mistakes. So here, the first step is start from the top one. So R, okay? So the bases are the same. What do you do to the car? You add. So 5 all over 2 plus, and this one is what? Minus 1 over 2 all over R raised to minus 3 all over 2. So that's the first step. Second one, now solve this. So it is similar to R raised to 1. So this is 5 all over 2 minus 1 all over 2. You get what? So 5 over 2 minus 1 over 2. What do you get? What do you get? So we have the LCM as 2. 2 and this is 5. Minus this and this is 1. So you get 4 over 2, which is equals to 2. So you get 2 there. All over what? R raised to minus 3 all over 2. Now, using the quotient property, so if this is minus and you're taking it up here, what do? Changes to what? Positive. So R raised to 2 times R raised to 3 all over 2. So you take it up here. So this power will change from negative to positive. Then using the product rule there, then this is equals to R raised to 2 plus 3 all over 2. Finally, what do you get? So this is equals to R raised to what? R raised to what? 7 over what? 7 all over 2. R raised to 7 all over 2. All right, the last example. Simplify 64s raised to 3 all over 7, and then all these raised to 1 all over 6. All that raised to 1 all over 6. Now, how should we simplify this? First of all, use the what? The power property. So is equals to 64 raised to 1 over 6, and then multiplied by s 3 over 7 times what? 1 all over 6. So that is our first step. So here, we can find the factors of this. So we know that 2 raised to 5 is equals to what? 32, right? So 2 raised to 6 would be equals to 64. So 2 raised to 6 will be equals to 64. So that means here it will be 2 raised to 6 and then raised to 1 over 6 there. And then multiply by what? So we can cancel that. We get 1. We cancel this. We get 1. 2. So s raised to 1. So 1 over 14 there. S raised to 1 over 14. So finally, when you simplify, then that and that will cancel. So our answer will finally be 2s raised to 1 over 14. 2s raised to 1 over 14. Any question? Anyone with any question? So I think this chapter 8 is a little bit simpler than the others, right? So which chapter was very hard? Chapter 6 or chapter 7? 6 or 7? So chapter 8 will be a little bit simpler because we'll be applying what we've done in the previous chapters. Before we go away, Valos, Benjamin, Gregory, Ashley, Victoria, Rachel, Bailey, Laura, Adam, Kaveh, Andrew, Destiny, Paul, Abby, Aliyah, Desma, Gillian Martinez, Remington, Mijon, Rayleigh, Eric, Kayla, Relay, Rock, Thompson, Samuel, William, Walkman. All right. See you guys on Friday. Leah.
I'm Maria.
You are the one?
Yeah,
You are.
Maria.
Oh, okay.
Thank you.